Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. When a switch becomes a router, explores a powerful type of network device that merges the functions of traditional switches and routers into a single, high-performance platform. A Layer 3 switch combines the frame-wording capabilities of a Layer 2 switch with the packet routing abilities of a router. These devices operate at both the data link and network layers using both MAC and IP addresses to make forwarding decisions. Layer 3 switches are typically deployed in larger or more complex networks, where speed, segmentation, and inter-subnet communication must all be handled efficiently. The reason Layer 3 switching exists is simple. Networks needed faster routing with fewer devices. Traditional setups relied on separate routers and switches, which introduced latency and additional configuration steps. By integrating routing capabilities into high-speed switching hardware, Layer 3 switches reduce the number of hops, decrease latency, and simplify management. These switches support scalable network design while improving performance, making them essential in modern enterprise environments, particularly at the core and distribution layers. Layer 3 switches provide a range of advanced functionality that sets them apart from their Layer 2 counterparts. They are aware of IP addresses, maintain a routing table, and can perform inter-VLAN routing without sending traffic to an external router. Unlike Layer 2 switches, which forward based solely on MAC addresses, Layer 3 switches examine packet headers and make decisions based on IP destination addresses. This capability allows them to forward traffic between different subnets and VLANs, acting as a routing engine within the switching platform. One of the most important differences between Layer 3 and Layer 2 switches is how they process traffic. A Layer 2 switch learns MAC addresses and uses them for frame forwarding, but it cannot make routing decisions or move traffic between subnets. A Layer 3 switch uses logical addressing and can route traffic just like a router. This expanded scope enables the device to participate in dynamic routing protocols, apply access control lists at the IP level, and manage inter-LAN traffic efficiently, all within the same piece of hardware. Routing inside a switch brings several advantages. First, decision-making happens faster due to the use of hardware-based logic known as ASICs, or application-specific integrated circuits. This reduces latency and allows packets to be routed almost instantly. Second, fewer devices are needed to manage routing and switching separately, simplifying the network design and reducing failure points. Finally, having one device handle both layers means fewer configuration points and greater control over traffic behavior across the entire network segment. Understanding Layer 3 interfaces is critical to configuring and managing these devices. One type is the routed interface, where a physical port is assigned an IP address and acts like a router port. Another is the SVI, or Switch Virtual Interface, which is a logical interface used for routing between VLANs. Each SVI corresponds to a VLAN and is assigned an IP address that serves as the default gateway for devices in that VLAN. These interfaces enable the switch to route traffic between VLANs internally without needing an external router. The routing table on a Layer 3 switch functions much like it does on a router. It holds destination networks and their associated next hop addresses or outgoing interfaces. When a packet arrives, the switch looks up the destination IP address in the routing table, determines the best route, and forwards it accordingly. These routes can be static, manually configured, or dynamic, learned through routing protocols. The ability to manage and view the routing table is essential for diagnosing connectivity and verifying path selection in large environments. Packet handling at Layer 3 includes several important steps. Once a routing decision is made, the switch encapsulates the packet in a new frame, updates the destination MAC address, and forwards it out to the correct interface. It also decrements the packet's TTL, or time to live, preventing infinite loops. These actions mirror those of a router but happen at switching speeds thanks to hardware acceleration. This combination of routing precision and switching efficiency is why Layer 3 switches are widely used in performance-sensitive environments. One of the most useful capabilities of Layer 3 switches is their ability to route between VLANs. This is known as inter-VLAN routing, and it happens through the use of SVIs. Each VLAN in the network has its own SVI, and traffic moving from one VLAN to another passes through the Layer 3 switch. Because all routing happens internally, the process is faster and requires fewer devices. This makes Layer 3 switches ideal for environments with multiple segments, departments, or access zones that need to communicate securely and efficiently. Common enterprise use cases for Layer 3 switches include deployment as core switches that route between major network segments, or as distribution layer devices that aggregate traffic from multiple access layer switches. In VLAN-dense environments, such as office buildings, university campuses, or data centers, Layer 3 switches handle inter-VLAN routing without the need for separate router. Their ability to maintain performance while segmenting traffic makes them central to scalable network architecture. Configuration tasks on a Layer 3 switch often include assigning IP addresses to SVIs, enabling routing protocols such as RIP or OSPF, and applying access control lists to filter traffic. These switches may also require settings for static routing or interface-level policies that govern how traffic is handled. Understanding the syntax and scope of these configuration commands is important for both the exam and real-world deployments. Layer 3 switch configuration often blends elements from router and switch command sets, so familiarity with both is essential. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Layer 3 switches support both static and dynamic routing protocols, allowing them to make complex forwarding decisions beyond basic switch operations. Static routes are manually configured and ideal for small, predictable environments. They offer control but require manual updates if the network topology changes. Dynamic routing protocols like RIP and OSPF are also available on many Layer 3 switches. These protocols enable the switch to discover new networks, adapt to changes, and share route information with other devices. Some switches also support neighbor discovery, allowing them to form relationships with peer devices and exchange updates automatically. Load balancing and redundancy are often implemented through equal-cost multipath routing, or ECMP. This feature allows a Layer 3 switch to distribute traffic across multiple paths that have the same route cost. Doing so prevents overloading a single link and improves overall performance. Redundant gateway settings ensure that traffic can still exit a subnet even if one path fails. Failover configurations using HSRP or VRRP allow multiple switches to provide gateway services with automatic transition in case of failure. These features enhance both performance and resilience in enterprise networks. Access control list integration is a powerful feature of Layer 3 switches. ACLs at this layer allow traffic filtering based on IP addresses, ports, and even protocols. Policies can be applied to incoming or outgoing traffic on specific interfaces, controlling what enters or leaves a given subnet. A CL rule order matters, as packets are compared to entries from top to bottom, with the first match determining the action. If no rule matches, a default deny may apply. These interface-level policies help enforce security boundaries and optimize traffic handling without requiring a separate firewall. Detroit's been a coming story with firewalls. KDM is public. When comparing Layer 3 switches to traditional routers, the performance difference is often significant. Because Layer 3 switches use specialized ASICs, they can perform routing functions at much higher speeds than software-based routers. This hardware-based decision-making makes Layer 3 switches ideal for high-throughput environments like campus cores or data center backbones. However, routers typically offer a wider range of features, such as support for advanced protocols, WAN interfaces, and more granular control options. Each has its place, and the choice depends on performance needs and feature requirements. One of the biggest benefits of Layer 3 switches is their ability to perform VLAN routing without external routers. This self-contained routing reduces latency, minimizes inter-depot traffic, and simplifies network design. Instead of sending VLAN traffic to a separate router and then back to the switch, the Layer 3 switch routes the traffic internally between SVI interfaces. This eliminates unnecessary hops and improves efficiency. It also makes troubleshooting easier, as all configurations can be managed from one central device rather than across multiple points. Troubleshooting Layer 3 switching often involves checking SVI configurations, verifying routing table entries, and ensuring that access control lists are not unintentionally blocking traffic. A common issue is misconfigured or missing SVI interfaces, which can prevent inter-VLAN communication. Incorrect subnet masks or missing default gateways can also create traffic black holes. Dynamic routing problems may stem from missing protocol settings or mismatched parameters between devices. Logs, ping tests, and tracer routes are helpful tools when diagnosing these types of issues. There are times when Layer 3 switching may not be the best option. In highly complex routing scenarios involving deep packet inspection, multi-protocol environments, or WAN optimization, traditional routers or specialized appliances may be more appropriate. Layer 3 switches may also lack the depth of features needed for advanced network address translation, policy-based routing, or inline security functions. Additionally, in security-focused deployments, dedicated firewalls and routers may offer superior visibility and control. Selecting the right tool requires understanding both the feature set and the environment's requirements. Layer 3 switches combine Layer 2 switching and Layer 3 routing capabilities, giving network designers and administrators a flexible, powerful tool. They support IP-based routing, perform inter-VLAN communication, and offer hardware-level performance advantages over routers in many use cases. Whether used in the core, distribution, or even large access layers, these switches simplify design, reduce device sprawl, and maintain scalability across enterprise networks. Their ability to balance routing functions with switching speed makes them an essential component in many modern infrastructures. Viewing the role of Layer 3 switches highlights their hybrid purpose. They provide the local traffic handling of a switch and the subnet spanning capabilities of a router. Their ability to route between VLANs, apply access controls, and support dynamic routing makes them invaluable in scalable network design. While not a full replacement for enterprise routers in all cases, Layer 3 switches offer an excellent balance of performance and functionality where high-speed local routing is required. Understanding how they work and when to use them is key to designing efficient and reliable networks. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.